Hi everyone, in this video I will explain how to find integral terms and also given the number of integral terms how to find the minimum exponent of the binomial expansion. Now let us take one PYQ. The number of integral terms in the binomial expansion of 5 to the power of 1 by 2 plus 7 to the power of 1 by 8 whole power 1016 is. This problem was given on April 8th 2025 in shift 2. Unless you listen this solution you cannot understand the next solution. Now let us start the problem. So given expression, it is 5 to the power of 1 by 2 plus 7 to the power of 1 by 8 whole power 1016. That is the given expression. To find the number of integral terms, I am writing general term. So general term TR plus 1 is equal to 1016 CR. It is 5 to the power of 1 by 2 whole power 1016 minus R 7 to the power of 1 by 8 whole power R NCR x power n minus R y power R. This can be written as 1016 CR. It is 5 to the power of 1016 minus R by 2. Next factor will become 7 to the power of R by 8. For this term to be integral term, there should not be 8th root, there should not be square root. Now let us check for what values of R 8th root and square root both are eliminated. Check one by one. For R is equal to, I am checking for R is equal to 0. R takes values from 0 to 1060. So if R becomes 0, 0 is divisible by 8, 8th root eliminated. For R is equal to 0, 1016 is divisible by 2, square root also eliminated. Therefore this term will become integer, this term will become integer, this is integer. So that term will become integral term. So for R is equal to 0, we are getting one integral term. Now for the remaining values of R, you need not check like that. Let us take LCM. LCM of 2, 8 is 8. So LCM of 2, 8 is 8. For the remaining values of R, just you go on adding 8. 0 plus 8 will become 8, 8 plus 8 will become 16, 16 plus 8 becomes 24 and so on. The maximum value of R is 1016. Check whether 1016 is divisible by 8 or not. 1016 divisible by 8 or not, I am checking. So this is 8 1 ja 8 2 1, 8 2 ja 16, 8 7 ja 56. So 1016 divisible by 8. Therefore I can take R is equal to 1016, maximum value of R 1016. So for R is equal to 0, 8, 16, so on 1016 terms are becoming integral terms. That means first term is integral term, 9th term is integral term, 17th term is integral term and so on. Last term also integral term. The number of terms in this sequence 127. Before one more term is there, R is equal to 0. So the number of integral terms are becoming 127 plus 1, that is 128. Therefore I can say number of I can say number of integral terms. So number of integral terms is 127 plus 1, that becomes 128. Therefore I can say option D is correct option. Further you see, to understand the next solution, listen this explanation. If the exponent is 1016, if the exponent is 1016, the number of integral terms is 128. First term is having square root, adding to 1018. If the exponent is 1018, the number of integral terms will become 128 only. Again add to 1020, number of integral terms will become 128 only. Again add to 1022. In this case also number of integral terms is 128. Again add to 1024. The number of integral terms, in this case it will become 129. Therefore, if the number of integral terms are 128, if the number of integral terms are 128, the exponents will become 1016, 1018, 1020, 1022. So the minimum value of the exponent will become 1016 is the minimum value of the exponent. Further you can see 1016 is multiple of 8. What is 8? 8 is LCM of 2, 8. So we are going to use this concept in the next solution. See one more PYQ. The least value of n belongs to capital N, for which the number of integral terms in the binomial expansion of cubed root of 7 plus 12th root of 11 whole power n is 183 is. This problem was given on January 29, 2025 in shift 2. So in this problem already he had given the number of integral terms is 183. We have to calculate the least value of the exponent, least value of n. See the procedure. So given expression is equal to 7 to the power of 1 by 3 plus 11 to the power of 1 by 12 whole power n. For the number of integral terms, write general term. General term of the binomial expansion NCR 7 to the power of 1 by 3 whole power n minus r, 11 to the power of 1 by 12 whole power r, NCR x power n minus r y power r. Further this can be written as NCR 7 to the power of n minus r by 3, 11 to the power of r by 12. For this term to be integral term, 12th root should be eliminated, cubed root also must be eliminated. So we have to give the values for r in such a way that 12th root must be eliminated, cubed root must be eliminated. But in the problem already he had given the number of integral terms is 183. We have to calculate the least value of the exponent. In the previous problem I told the number of integral terms is 183. n must be multiple of 12, that is LCM of 3, 12. Therefore for minimum value of exponent n. Let us see now. For r is equal to 0, I am checking whether this term is becoming integral term or not. For r is equal to 0, 0 is divisible by 12. R is equal to 0, n by 3. I told that n is multiple of 12, therefore n is divisible by 3. This term is integer, this term is integer, this term is integer. Therefore this total product is integer, that term will become integral term. So for r is equal to 0, we are getting integral term. For the remaining values of r, you need not check like that. LCM of 3, 12 is 12. Go on adding 12. 0 plus 12 becomes 12. 12 plus 12 becomes 24. 24 plus 12 becomes 36, so on. The maximum value of r will become r will become n. But I already told that n is multiple of 12. Therefore I can take the last value of r will become n itself, because n is multiple of 12. So all these numbers are multiples of 12. The number of terms in the sequence will become n by 12, but before one more term is there. Therefore the total number of integral terms will become n by 12 plus 1. Therefore number of integral terms is n by 12 plus 1. But in the problem he had given number of integral terms is 183. Therefore n by 12 becomes 182. n becomes 182 multiplied with 12. So 12 2 ja 24. 12 8 ja 96. 96 plus 2 becomes 98. 12 1 ja 12. 12 plus 9 becomes 21. So in the above binomial expansion, if the number of integral terms is 183, the minimum exponent of the binomial expression will become 2184. See which option is the correct option. Option A is the correct option. Listening and practicing both are equally important. So here I am giving 2 PYQs for your practice. For more videos, subscribe.